session, let's consider a new module, okay? It's bit manipulation. It's actually very easy, crackable, a programming kind of questions can be asked in this chapter, okay? So this is going to be our flow. We'll initially understand how to convert decimal to binary, okay? I know most of you guys would perhaps know it, but let's initially start with a simple program of this kind and then understand the basic operators that we will be studying totally 6 kind of operations, that is AND, OR, NOT, XOR, left shift and then right shift. And then the programs pertaining to all these operations that are most possibly asked. Alright. So this shall give you a basic ideology on how to solve any kind of question, how to approach any basic question that you might come across in your interviews or placement job candidates. Right? So let's initially start with the decimal to binary conversion. I suppose most of you guys would know it, but suppose that if you don't know it, so let's consider n's value is 6. Alright. So to convert this decimal to binary, what should you do? First of all, divide by 2. Alright, so when you divide by 2, what happens? Divide by 2. 2 3s are 6. Alright, so what is the remainder? The remainder is going to be 0. Alright, again, I divided by 2. Okay, so what is going to be the quotient? 2 1s are 2. So what is the remainder? 1. Alright, again I divide by 2. So what will happen? You can't divide it. So 0, what is the remainder? The remainder is 1. And then you read it in this fashion. So 6 binary representation is 0, 1, 1, 0. Alright, so let's consider another number 9. Alright, so 9. What will happen? 2, 2 4s are 8. Right, so initially you will write the quotient here and the remainder here after dividing by 2. This is the idea, okay? So 2 4s are 8. And so what will happen? The remainder is 1. Again you divide by 2. 2 2s are 4. What is the remainder? The remainder shall be 0. Again you divide by 2. So 2 1s are 2. This is the quotient. The remainder is 0. So again you try dividing it by 2. What will happen? You get 0. You can't divide it. The quotient is 0. The remainder is 1. And then you read it in this fashion. So 9's binary representation is, it is going to be 0, 1, 0, 0, 1. Alright. But leading zeros, you need not consider it. 1, 0, 0, 1 is far more than enough. Alright. So another easy method, to write this. You need not always start from this, but this is the idea. You divide by 2, you take the note of the quotient and the remainder, and then you read it in the reverse fashion. Alright, so this is the idea. Divide it by 2, know the quotient, know the remainder, and read the remainder in reverse fashion. And until when should I read this quotient? Until the quotient hits 0. Alright, so these are the 4 things that you have to know. Until the quotient hits 0, divide by 2, get the note of the quotient and the remainder, store the remainder, and then read the remainder in the reverse fashion. Alright. So, rather doing like this during every time from decimal to binary conversion, what can you do is write this 0, 1, 2, 3. This is one way of writing it, or you can write it as 2 power 0, 2 power 1, 2 power 2, 2 power 3. Or I personally prefer the last method, alright? 1, 2, 4 and 8. Fine. We're going to have it as 1, 2, 4 and 8 right now. I suppose 9. So 9. 9 can be written as start from here. 8 plus 1 is 9. So the others fill it with 0. Alright. If it's going to be 5. Alright. So 4 plus 1 is 5. Fill the others with 0. If it's going to be 3, then 2 plus 1 is 3. Fill the others with 0. Start from your left hand side and go towards the right. Okay, you can't have 4 at all, right? So suppose again 3, right? So 3 or 5, whatever. Okay, let's have 5. So 7. Here let's have a new number 7. So I start from my left hand side. Of course, yes, I can't have 1 at 8, right? So I start with having 1 at 4. Alright? So possibly I should have 1 again here. So it leads to 6. Again, I have to add 1 to it. Obviously, this should be 0. So this gives me a value of 7. So this is a most easy way of, converting a decimal to binary. So let's look at the program, alright? So what did we know? We just saw that, fine, any number n I have, you're supposed to divide it by 2. Any number n I have, Suppose you divide it by 2, get the quotient, get the remainder, store what? The remainder, and move until the quotient hits a value of 0. So let's have an instance of 5 2 here. 2 2s are 4, remainder is 1, 2, 1s are 2, 0, 2. So it's going to be 0 and 1. So 0, 1, 0, 1 is going to be what? This is going to be our binary representation of the number 5. Alright, so now let's look at the program. Let's have it a name of fun. Alright, so what should I get as input? I should get the number n as input, right? So int n, this is given to this function. Alright, this function is not returning anything. I would rather like to print this value directly inside this function. So it's going to return void, it's not returning anything. And I would like to give a name fun, and it's taking the n as input. N is what? The decimal number as input. Alright, so right now I have to store the value of this remainder. And I would suggest you guys, you can either have it, store it in the value of an array. Alright, or you can store it as a string. Alright, so I am going with the string format. Just try out, for a vector of int format or vector of bool format. String k, there you go. So I am declaring an empty string to store what? To store my binary representation. Alright, yes. So this is my solution string that I will be printing. So until when? So this is going to be an iterative format. Okay, I'll have to store the value of this in an iterative format. I'll have to store here, I'll have to store here, I'll have to store here again and again. Until when? Until I get a value of 0 here, right? So until n reaches a value of 0. When n reaches a value of 0, it simply means I'll have to stop. So can I tell until n is greater than 0, run until n is greater than 0. So when I run, store the value of q, store the value of r. Can I say in this manner? So until n is greater than 0, run. Exactly. While n is greater than 0, alright, so what should I do? While n is greater than 0, get the value of this remainder. What is this remainder? N mod 2, right? So remainder is equal to what? N mod 2, but rather we are storing this remainder, right? So k dot pushback of n mod 2. Alright, makes sense? So now the quotient will be what? Divided by 2, n by 2, 5 by 2, right? So this is n, it's 5 by 2, yes. So n is equal to n by 2. This is going to occur again and again until when? Until n is greater than 0. Okay, but right now if you notice, so suppose if n is 5, it goes in, an empty string is declared. So yes, 5 is greater than 0. K dot pushback of n mod 2. 5 mod 2 is what? 1. So k will have a value of 1 right now. Okay, and then what will happen? So let's consider 6, okay? If you are going to consider 6, right? 2 3s are 6, 0, 2, 1s are 2. So it's going to be 1 1 0. So for this, if I'm going to consider this, k will initially have the value of 0, right? N will be 6. 6 is greater than 0. So k will push back of n mod 2. So which is going to be 6 mod 2, 0. And then n is equal to n by 2. So n will hold the value of 3. Again it will go, it is n. 3 is greater than 0. Yes. So k dot pushback of 3 mod 2. What is 3 mod 2? 1. So it will get stored here. Then again n is equal to n by 2. 3 by 2 will get a value of 1. So 1 is again greater than 0. K dot pushback of 1 mod 2. What is 1 mod 2? It is 1 again. So you get 0 1 1. But what is the desired value? 1 1 0. The reverse of this. Alright. So how do I reverse this thing? You have an inbuilt function, alright? It is the reverse of k dot begin, comma k dot end. So the original string will actually get reversed, alright? And then see out. Okay, that's it. So you will get the binary representation of the given integer. Okay. I hope you understood this. So let's look at the basic operators in the next module, right?